we're going to go over how to write a chapter block for um, environmental studies. You'll write a number of these throughout the year with the idea that creating them will give you an ability to read the text with an understanding. So not just reading to skim or reading to just get a little bit of information and then soon forgetting it, but reading to actually understand and remember. And it's an important skill to have, especially as your volume of reading increases as the years go on and the amount of material you're supposed to understand goes up as well. And but being able to read a text and learn from the text is an important skill for college as well. So if we look at your textbook, Chapter 20, Global Climate Change, and the first thing that you can start by doing is a pre-read of the chapter. And you might look at the beginning and then look at the learning objectives and introduction to climate change, read the titles. And this is giving your mind something to focus on when you actually come back and do the reading. So you would read these learning objectives, explain radiative forcing, greenhouse gases and the enhanced greenhouse effect, explain how climate models project future climate conditions, describe the importance of extreme and unpredictable climate change. And then going through the text here, you look at certain definitions that might come up in the text. I see one that is italicized, the phenological spring, and that's determined when the buds of specific plants open, and in autumn when leaves of specific trees turn color and fall. Also look at figures, and here we see the mean annual global temperature in figure 20.1 plotted up versus the year, and we see a general trend upward, and if you read the captions of those as well. Also looking in the text here, I see the next section is the causes of global climate change. So this is just a pre-read. I see greenhouse gases as a definition here. And greenhouse gases are gases that absorb radiated heat from the sun, thereby increasing the temperature of the atmosphere. And then it says it over on the side too, gives a definition, a greenhouse gas. A gas that absorbs infrared radiation, carbon dioxide, methane, nitrous oxide, chlorofluorocarbons, and tropospheric ozone are all greenhouse gases. I see another definition below it. Well, I see parts per million as well. And parts per million says ppm, parts per million, meaning the amount of equal pieces out of a million pieces available. And infrared radiation pops up. So right there where it talks radiated heat from the sun, radiation that has wavelengths longer than that of visible light, but shorter than that of radio waves. Most of the energy absorbed by the Earth is radiated as infrared radiation, which greenhouse gases can absorb. See, even this little pre-read is giving your brain something that's what's to come in the reading, which will then make what you actually read stick better. It talks about radiative forcing, the capacity of various gases to affect the balance of energy entering and leaving the atmosphere. And then there's this table that gives pre-industrial concentrations and the 2010 concentrations of carbon dioxide, methane, nitrous oxide, chlorofluorocarbon 12, and CFC 11. Those are 0 because they didn't exist before we made them. And then another diagram up here on the amount of carbon dioxide concentrations versus the year and the annual or the increase of that. And I would read the caption to that. Here's a definition for radiative forcing: the capacity of a gas to affect the balance and energy that enters and leaves the Earth's atmosphere, measured in units of power per unit area, usually watts per square meter. Okay, so I continue through the whole chapter going over the topics and going over the definitions and going over the figures, and it would give yourself a good thing of what to come. So just continue through that. You can press pause on the video and go through your chapter 20. I would go all the way to the end here, and in the end of the chapter, it has a review of learning objectives with selected key terms. And I would read that as a pre-read as well. And the first thing says, explain radiative forcing, greenhouse gases, and the enhanced greenhouse effect. Radiative forcing is the capacity of a gas to affect the balance of energy that enters and leaves the atmosphere. Greenhouse gases are the gases in the Earth's atmosphere that absorb infrared radiation. The enhanced greenhouse effect is the additional warming produced by increased levels of gases that absorb infrared radiation, heat. The Intergovernmental Panel on Climate Change concluded in 2007 that human-produced greenhouse gases are the most likely cause of recent climate warming, and that the world will almost certainly warm substantially during the 21st century. Okay, so I would go through and read the rest of those as well as a pre-read. So press pause and do that. Okay, so actually going back to the beginning of this here. Oops. Global climate change. So what we'll discuss today is how to write this chapter block. Okay, you would have a heading that describes that, your name, date, etc., and also a title. Just chapter 20. Global climate change. Okay. Now, the first part of this is the introduction. So, well, okay, first the sections of the chapter block. The sections are the pre-read, read, outline. The actual written part of this is outline, definitions, summary for whatever sections you have, and figures. And I make the students do 5 figures each for these. So you'll do 5 figures for the whole chapter block, not for each section, but for the whole chapter block. And those figures should include the caption as well. Okay, so then go back and let's begin our reading. So let's read this introductory part on global climate change. Just press pause and read that. Good. Okay, so after we've done our reading now, what I like to do is underline as I read or highlight of stuff that I'm going to write down in my summary. So the first part is the outline, so that's just going to be introduction. It's just an introduction part there. There was a definition in there called for wedge, so we could see that definition on with wedges. So I decided to put that in as a definition. Right there. And I also would have underlined some things as I went through and did the reading. So just as so you see what I have here, I'll underline the parts that I have. Okay. Well, I'll just bracket that. Doubling of pre-historical levels, 7 billion fewer tons generated each year by 2056 for a wedge. If we want to avoid that doubling, reductions, these are wedges represent 1 billion ton per year. There's 15 technologies that can already do that. 2 billion cars from 30 to 60 is an example, 30 to 60 miles per gallon. Install carbon capture and storage at 800 large coal-fired power plants. Stop all deforestation. Actually, probably a combination of deforestation and reforestation. Oh, it says that right here. Balance between deforestation and reforestation. Add twice today's nuclear energy output to displace coal. Today, 17% of the world's electricity comes from nuclear. We have to replace existing coal-fired power plants with nuclear power facilities to reduce greenhouse gases. And making these changes in economics, politics, energy, agriculture, human behavior, such as those associated with these wedges, will be necessary to curb climate change. So this is all about this wedge activity, which we'll actually do in class. We'll do this activity. And it's described here in the text. So with those underlining things, I'm now ready to do my definitions part. I just have one, which is a wedge. And a technology that when implemented and upscaled So I've already done my reading and underlining, and now I'm summarizing it in my brain to try to get it to stick, so to speak. Can achieve a of 1 billion tons of carbon emissions per year by 2056. They came up with the activity of wedges in 2006. 50 years from that is 2056. So having really basically done nothing for the last 7 years, we have to catch up. Now time to write the summary of that introduction section using the underlined stuff I have as a guide. So I wrote, it is no longer whether climate change will occur but at what rate. With what effects, and what we can do about it. I use different colors to help distinguish different facts. The biggest culprit is an increase in anthropogenic CO2, human-produced CO2. A proposal from the CMI, assuming I'm reading this, that would be enough to let me remember what CMI is, Climate Mitigation Institute, is to keep future atmospheric carbon below a doubling of the pre-industrial level. To do this, we need 7 billion fewer tons each year by 2056 than expected. "15 technologies to do this. Exist to do this. Today or more," but that's just, they identified 15. And each is worth 1 wedge or 1 billion tons of reduction. We need 7 wedges examples. increase fuel economy, from 30 miles per gallon to 60 miles per gallon. 2, install carbon capture and storage. At 800 large coal plants. 3, add twice nuclear capacity. And 4, stop all deforestation. Which is a balance between, actually a balance between deforestation and reforestation. Okay. Making changes in economics, policies, politics, energy, agriculture, and human behavior will be necessary to curb climate change. And I don't really see a figure to include in this opening section, so we'll avoid that or skip that part. Okay, for this section. Jen, and go on and read the next part. Trying to delete all these. Hold on. Okay, the next part in the reading will take us through an introduction to climate change, to the causes of global climate change there. So we'll do a little definition, summary, and figure for that section. So I would now read it. So start with the objectives, read it, look at the figures, all of that as you go through your reading, underline, etc. So do that now. Okay, good. So now in my, actually, let's continue to the reading. Okay, so I've gone through and underlined and noted definitions that I'm going to include for this section. 2. This section will title Introduction to Climate Change, and there's multiple sections within this one, so, but I don't want to have too much per part that I have to do a summary on and that. So I'm just doing the introduction to this introduction. So it's called Introduction to Climate Change, but the first part I'm going to do is just the intro and we did the reading, you should have done the reading up to the causes of global climate change, basically that page, just that first page there. So in the introduction, I have some definitions, two definitions: phenological spring and that one said that determined by when buds of specific plants open. And then in autumn, when leaves of specific trees change color and fall. And I also had the definition emissions scenario. Prediction about the amounts rate and mix of future greenhouse gases. All right. And then as a summary for this section, I have 2010 and 2005 the hottest years since 1880s. We had detailed records. And the 16 warmest years since the 1880s. Have occurred since 1990. The 16 of the warmest years on record have occurred since 1990. Earlier temperatures are reconstructed. Using tree rings, lake and ocean sediments, stalagmites, small air bubbles in ancient ice, and coral reefs as some examples of proxies. Spring in the northern hemisphere, now comes 6 days earlier. than in 1959. Autumn is delayed 5 days. In the U.S., experienced an increase in the frequency of extreme heat stress events. Sea level rise, is now increased to 3 centimeters per decade. Glaciers worldwide have retreated, or are retreating. And severe weather events are on the rise. Scientists conclude that temperature increased in the last century. Scientists conclude that the temperature rise in the last century highly unlikely from natural causes, and that human-produced greenhouse gases are most likely the cause. The remainder of this century we will experience significant additional climate change. Human action largely responsible. The Intergovernmental Panel on Climate Change hundreds of climate scientists report. A 0.2 degrees C increase in global temperatures in each of the next 2 decades. By 2100, 1.8 to 4 degrees C increase and warmest on Earth. In the last tens of millions of years. Okay, so that's a summary and the definition. And now I'm going to place a figure in there. We see the figure is over showing the mean annual global temperature versus the year since 1960. And it doesn't have to be specific and exact. Something like that. And with that, a caption, mean annual global temperature from 1960 to 2010, rise over decades, continues to go up. The rate of it going up is increasing as well. And then I would just continue on with the rest of the chapter, saying that this does take time, but as you do it, you're actually learning a lot. You can lessen down a little bit on the summaries in some areas. You know, focus on definitions, maybe condense your summaries a bit. You only have to do 5 figures, make sure they're scientifically relevant. Okay, and then continue through to the end of the chapter.